So let's talk about this concept right here. So hypothesis testing, this is what we're talking before. Let me quickly go quickly to a couple stuff. Yeah. Let's do a quick review of how we did. Just to put you in the mood. You see what we had. I'm gonna go over this one quickly. On Tuesday, when we came, we talk about the claim. A claim is something that can be rejected and then a reject. Okay, and then I mean a claim is that can be, that can be true or false. That's what I meant mainly. So a claim, it can be rejected. It's rejected if it's false. Let me use a different color so it doesn't match the one that we did before. Okay. A claim, when somebody make a claim, it can be rejected. It will be rejected if it's assumed to be false. Okay, it's not going to be rejected if it's assumed to be true. Okay. So once you do a claim, for example, someone say Walmart is so expensive that that the specific candy is more than $3. Okay, then you're gonna do some study. If you find that this is a false claim, you're gonna say if it's true, suppose this is a true statement. If you do not reject, if you say do not reject the claim, the claims. So we're gonna say do not reject, something like that. You're gonna say based on that. No, I don't want to say do not reject. You suppose the claim is false. After you say that, suppose the claim is false. It's depending on how it's saying. Suppose the claim is false. You're gonna say there's not enough evidence to support the claim that Walmart is expensive. Okay, I put 3 dots, that Walmart is expensive, or the price of this candy is more than $3. If it's false, you're gonna say there's enough evidence to support the claim. Just like we're in a courtroom. If the person is guilty, you're gonna say we have sufficient evidence that the person did the crime. If the person, you find out, if you based on the statement, you find out the person is not guilty, you can say we do not have enough evidence to condemn this person, something like that. Okay, that's based on what we are trying to say. So after that, I'll give you the formal way to work them out. Okay, and then that was just an example here, and then we'll give an example, and then something called H0, and then the H alternative, something like that. We'll talk about that. Okay, and then first I'll give an example here. There's a claim. This one's the dealer is paying S's. Assume that because it is means equals, so I can say that'll be the claim here for that one. And if the claim happened to be an HO, and here the claim happened to be an H1. I think I explained to you that at the beginning of the class that HO only accept equalities, while H1, HA or H1 only accept inequalities. So that's very important to remember. So whenever you have the given example, you don't mess it up. Okay, for HO, wow, that thing again. Oopsie. For HO, you only accept equalities. Okay, and then for HA, it can be inequalities. Okay, so let's keep working. And then we spoke about, we have this example here, and then it also explain to you something called level of significance alpha, right here. Suppose I say I'm 95% confident about something, the alpha will be that the 5% when which I'm not confident at all. And I just said last time that you cannot say about, whenever you do statistics or whenever you do your own study, you don't want to say you 100% confident about something, okay? So you have to say 99.9%, something like that, etc. Okay? So that alpha will be what we don't want to have. And then after we spoke about some level of significance, sometimes I can use the most current one would be 0.05, but you can also 0.01, it can also be anything, okay? But by default, it's gonna be 0.05. And then I also introduce you something called the test statistics that we're gonna be using, okay? And which you're gonna have, right now we're working for proportion, okay? So you're gonna be introducing this value. So you need to find p hat, and then p naught is gonna be the one from the population, okay? So I'll give an examples. We work on the example right here, okay? I did say there were two ways to make decisions to reject the null. You can the traditional way, if your z naught is greater than alpha, z alpha, then you're gonna reject it, say reject h naught. If not, you're gonna say no, reject h naught. But I also explained to you something called the p-value method, in which that if your p-value is greater than alpha, you're gonna say do not reject h naught. Okay? But if it says an alpha, you're gonna say reject h naught. That's called the p-value method. Another example also for you how to find the p-value. Okay, so that's a quick definition of the p-value and how to interpret the p-value. And then we keep working, and then these are almost the steps. First of all, you come up with your claim, then you're gonna write the hypothesis. Then you will need to know what's your level of significance. If it's not given by default, it's gonna be 0.05. Then about the z-score, and then you do all the other stuff, compare with the p-value. And then I did say we're gonna have almost 3 cases. Okay, all the time 3 cases, either one of them will be the one that we're gonna be working on. Then you're gonna complete the test statistics based on the formula I gave you earlier. I said to write it down, and you're gonna be able to complete the p-value. The way to complete the p-value, so we also talk about the p-value over here as well. The way to complete it is gonna be that way. So it depends. If you have a left tail, and this is the formula. If you have a right tail, and this is the formula, and so on. And if you have the tail, and then we do one of the others at the bottom. The good thing about it is that if you're using the TI-84, it can calculate for you easily. Or if you're using the StatCrunch, that'll be easily calculated for you, okay? We did do an example on StatCrunch last time, and then I think that was the example here. Let me see. I mean, these are different examples of the last one we did, or what was this one right here? Let me see. Right here, we did an example on StatCrunch and how to do it. Okay. So, and then we're gonna do some more examples, and then also you can see why is the test statistic is right here. We're gonna say the z-stat and so on. Okay. Then we got to put the p-value. This is why I got the p-value. Okay. And then because this one say more than 70% or 0.7, so here, this is your null hypothesis as 0.07, just like we have over here. Okay, you put the equal sign for that one, and the other one will be greater than. That means this is going to be a right tail test. Okay. So whenever you eat the StatCrunch, you're gonna say stat, proportion, one step even with summaries, and so on. And that's what we did last time. And then I also explained more definition how to express it, and then so on. Okay, just a quick reminder also about the step of the hypothesis testing. Before I continue, does anybody have any question for me? Okay, nobody said anything, so I'm gonna be continuing. So the first step, this one say hypothesize. State you the hypothesis about the population of the parameter. Suppose I say, for example, this is my claim. I claim P is greater than P0, something like that. I mean P because P can be any number. This is like a specific number. This is what I claim. Like if I'm trying to do a general example, I could have put an example. I'm gonna say P is greater than 0.05 or 0.6, something like that. I can also do that as well. Okay, but instead of putting a number, as I put peanut, that's like just a general any number, like a variable to help me out. Okay. And then what you're gonna be doing, so if the first thing you state your hypothesis about the population parameter. Okay, that's means do these things. HO, H1 or HA. Choose significance level, enter statistics. Check requirements. You know the check requirements is gonna be the NP must be greater than 10. And then the test statistic will be the Z naught. You need to find out, I will show the formula. The significance level will be alpha. If alpha is not given, it's gonna be by default 0.05. 0.05. Okay, and then set your assumptions. And then compute the test statistic and find the p-value. You need to find the p-value, okay, and then compare it. So you're gonna reject or fail the null hypothesis based on what we're gonna be. This is the interpretation. Okay, you're gonna do the conclusion. The way we're gonna be doing the conclusion, gonna say we have enough evidence that this is true, or we don't have enough evidence this is true, something like that. Okay, that's how I'm gonna make the conclusion. So you can save this as the steps for you to remember and write down in the little notes. Okay, that's a reminder. So this one say each year, 5% of the world tiger population is killed by poachers. Now there's a campaign to educate people on the problem. As this percentage gone down, 200 tigers were observed in 18 were killed by poachers. So this one say 5% of the whole tiger is killed. So you know that it means equal, right? So what we're gonna be doing, if you have to do, this is your claim that each year is being killed. Okay, you want to know if it go down. Okay, so what we're gonna be doing, if you do this is your claim. The claim is P is equal to 5%. Okay, each year. So if I want to do my hypothesis, okay, you're gonna put H naught and H1. I mean HA. In your book is HA. But this one has the equal sign, so I'm gonna say P is equal to 0.05. Okay. So what we're gonna be doing is the next one. Because this one say you want to know whether it goes down. Go down means you have to be less than. So I'm gonna put P is less than 0.05. So I'm gonna do my study and figure out whether it goes down or not, something like that. Okay. So this is what we did. This is the hypothesis I just actually said earlier. HO is something like that, and then this is your hypothesis. Okay. We can do that study all the way, but we're gonna stop for now. We're gonna come back to it after. Okay. So this is another example so you can compare. So this one say 90% of our restaurant fail after 1 year. Is that number different from Chinese restaurant of the something like that? You want to know whether that number is different. Okay, so let's see. So this one 90% fail, that's in P, is equal to 0.90 fail every year. That will be H naught. My HA will be, I don't know anybody can give an idea because this one say, is that number different for Chinese restaurants? That will be the question. What symbol you think should I put here? Should I put less than, greater than, or not equal to? Which symbol you think would be fine here? Which symbol will fit different? Different, it can be any directions, it can be either greater or less than. We don't know for different. So which symbol you think will fit that? Which symbol we think will fit that? Is it greater than, less than, or different? You can use greater than somehow, but because it's a different, so what are you better use this one? It's gonna be different because it's the terms are different. 0.90. Because it's a different. In that case, this become a two-tail test. Okay, they become a two-tail. All right. This is what we got. Now, based on what we were saying earlier, the next step is to make sure, hold on, give me 1 moment. What's the next step again? The one say, state your hypothesis about whether prepare, choose a single level, and test statistics, your requirements. So we need to check the requirements now. So by default, if there's no thing given to us, what was the question? When do we use the equal in? I don't understand the question. When do we use equal sign? That's the question. Oh, that's different because the things are different. Whenever we say it's different than what we're trying to do, okay? So the equal sign, the statute I'll talk about, let me just go back to the previous notes right here. See right here? This one stands for different. Okay. So if you say different, so we have to use that symbol. So okay, now the next step was to, let's see, where was I? You say choose a significance value. No, now they didn't tell you anything about alpha. We're gonna assume the alpha to be 0.05. Next step is to check the requirements. Okay, want to know whether it is gonna be greater than 10, something like that. We have to check that. So let's go back to our notes. Where are we? So let's see. So you're gonna check your notes. You're gonna say, see alpha by default because they say intended alpha is 0.05 by default. Okay. Then you're gonna check whether this is greater than 10. As you can see, 300 times 0.05 is greater than 10. That's going to be 15. And also the other one also give you greater than 10. Therefore, you can use the test statistics. Okay, so the assumptions are met. So we say that's going to be random. Okay, as that 300 target were randomly selected, and that there were more than 2,000 targets in the world, something like that. Okay, so the only term I wanted to focus on is the term random. Okay, randomly selected. So once you do that, then now you should be fine. And then your sample is big enough. So focus on this little two terms only. because this wording they have over here will change over time, okay? Also, the other example, we try to do the same thing. Here we have also greater than 10 as well, so we can use the test statistics. Okay, again, random, and then large sample. Now, let's see if we can do that one of them online. Now, so assuming that you guys know how to use StatCrunch. So once you input the value inside, you're gonna get that table, okay? So this one's equal than 0.05, and then this is for the very first one that we're doing, and it have to be less than, okay? So you know what, let me just go back to that problem so you don't get confused. Right here, this one. So we're gonna plug this things inside the formula. So give me a moment. Let me just stop sharing and share let me go to StatCrunch. So my stat lab. I'm gonna go to StatCrunch right now. StatCrunch, log into StatCrunch. Okay, let me share my screen with you. Share the screen. Here we go, share StatCrunch. Okay, so I'm gonna go to Stat, okay, and then you're gonna go to Z-Stat, something like that, and you're gonna go to one sample, and they're gonna say with summary, okay? You click on that. Then you're gonna put your sample mean. No. That's the other one. I'm doing the one for proportion. So yeah, I'm doing the one for proportion. I'm gonna have to go the other way around. So let's go. This is for the other one. Okay. You're gonna go to Stat. Okay. In this case, I'm gonna have to go to proportion. Right here. Then I'm gonna say one sample with summary. So here I'm going to put the number of successes. This one say 200 targets were observed and 18 were killed. Okay, so 18 were killed, then 300. Okay, now for my HP, I'm going to have to put 0.05 HO, and then this one I'm going to have to select less than, because they say you want to be as easy less than. Okay. So, and then my significance level is 0.05 because by default I don't see it. I like to get some other stuff. I would like to get that 25 on the side. I would also have to show that's me. I don't have to put this one. This is unimportant. Okay, and I'm gonna say compute. You don't really need these two. Okay. So just for me, I like to see the critical value because I did spoke about Z naught and Z alpha, but I would like to see that as well. So let's compute. This is what we have. Okay. So sample proportion is there, 0.06, and etc. Then your Z alpha is 0.79, and your p-value is 0.7866, something like that. Okay, so let's compare to what we have earlier. So if you Z alpha, this is what we can do now. Well, let's talk about it before I compare. Before I go to the notes. Notice that your p-value is 0.7866. 66. This is greater than alpha. If it's greater than alpha, that means do not reject HO. HO. That means if you do not reject HO, that means this is fine. You have no evidence that this is less than 5%. That's what it means. So there is no evidence. No evidence that whatever you're talking is less than 5%. Okay, so you can just copy the sentence that you have in the problem and then work it out. So let me go back to the problem. This I'll just give you an idea. You start sharing that and then share the notes that we have over here. Yeah, they're my sharing the notes, right? Share. Okay. This is what we have. Let me just go back to the quick part right here. Here. As you can see, the same answer. We have 0.7, something like that. And then this is your Z stat right here. Okay, etc. So this is what we say. And p-value is 0.79. Okay. So if 5% of the tigers are killed by poaching, and if another sample is observed, there is a 79% chance to have a sample portion less than 6%. 79% is very high. I don't really like the wording this book is using. I like the wording they use, and the court. You can just say, because if you compare this one, is greater than alpha. That's mean we have no evidence for that's mean do not reject HO. That's why I say e-learning class. Okay, do not reject HO. Okay, you're gonna say we do not have it. I mean, we do not have enough evidence. Okay, you can say we have enough evidence to not support the claim. Say that this what I want to know. Whether we want to know whether now there's a campaign to educate people on the problem. Has this percentage gone down? Gonna say no, this percentage gone down. It didn't go down because we have no evidence that it went down based on what we have over here. We have no evidence that it went down. Okay, so because you refer to reject HO, okay, that's mean you have no evidence there equal that. That's mean you have no evidence for HHA for it to be less than 1.05. You have no evidence for that. Okay. Any questions? Okay, nobody say anything. So for the other example, we can also do the same idea. As you can see here, this is point less than alpha. I mean less than alpha. Let's see. In this case, because this one is less than 0.05, you're gonna say reject HO. So if you reject HO, I'm gonna have to reject that one. Okay. The question whether that number is different, you're gonna say yes. We have evidence that it is different. Okay. So it's different. All right. So if you want, you can use that wording here, but we don't really use that much wording because Pearson is a general that give you general ideas, but that's how we do it. You're gonna say, is even what the claim is 90% of us failed fair. So is there a number different from that? You're gonna say, reject HO. There is no evidence. I mean, there is evidence to support that the number is different for Chinese, okay, etc. Before you put that, is because of the with the confidence, because say 5% level, you can also just put at the 5, you can also say at the, just make sure that you know whichever you did it, you can say at the 5% significance level, there's evidence to support something like that, because you have to be statistically correct whenever you say something like that. Okay. So all of these are going to be on the test. Yeah, you have to look at the test review. Okay. Etc. All right. So let's see what I can do now. I do have other examples. Okay, let's see. Let's look at this one. Let's look at this one. This one say, if your p-value is less than alpha, you reject HO and accept HA and set the conclusion. If your p-value is greater than alpha, you're gonna say fail to reject HO, or you can say do not reject HO and just say that we do not have statistically significant evidence to make a conclusion. So as I can tell you, as I was telling you, that the way sometimes the book is saying is confusing, but this is the right way of this is the right way to do to make a conclusion. Okay, so you're gonna say we don't have enough evidence. You can say the word evidence, stuff like that. Okay, these are the wording that you're gonna need to use whenever you talk to somebody. Okay, so that just had the example we did earlier, like this one over here. So as you can see, P is equal to 0.79 was greater than alpha. You're gonna say fail to reject HO. This is the best way to express your information. Like over here, the way they express it is extremely confusing for average Joe. Okay, so we can use it, but I don't like using it, and I prefer to use the way most people are gonna understand. So I'm gonna say it, because your p-value is greater than alpha, you're gonna say, and then you fail to reject HO. Okay, so you're gonna say there is statistically insignificant evidence to support the claim. You don't need to put insignificant, that you don't have to put this term. I mean, that's exaggeration. You can just say there is statistical evidence to support the claim that since the campaign began, less than 5% of the world target probability scale. You just repeat the same sentence. Okay. This one says significant. So let me just see where's that. I know probably why they put it that way. Okay. So I like to put it simple, but that's okay. So you're gonna say there is this. Okay, let's do it again for one more time so you can see. You got P is equal to 0.05. That was, and P not equal to, was again P less than 0.05. Okay. This one say each year 5% of the world by skill by poachers. Now there is a campaign to educate people on the problem as this percent go down. Okay, apparently this one's insignificant evidence. And significant means that there's no evidence at all. Okay. To support the claim that since the campaign began, then it's less than 5% of the world trigger policy scale. So that's mean fail to reject HO. That's mean there is no evidence for that part, because it says if do not reject HO, there's no evidence for that. And this is the right point we need to do. Okay, so that's a lot of sentence. They can just say there's not enough evidence to support the claim that is less than 5%. I mean, that's the way, but you can also use that kind of wording if you want to. Okay, but just pay attention. Sometimes the wording, whenever you do the expression, can be very complicated or very simple. Okay, but the idea is that you need to keep this one into mind. Let me just go back again to this part right here. Keep this one into mind. So if your p-value is less than alpha, you're gonna say reject HO. Okay, so suppose you got HO right here, you got H1 right here, and you got this thing. This one say if p-value is less than alpha, then I reject HO. Over there, you got HO, you got H1. While we have p-value is greater than alpha, then now we reject HO. That's mean you're gonna have to get rid of the H1. Okay, so you're gonna be either or, either in or out. That's the one that's gonna help you to make the decision. Okay, so if you fail to reject HO, you're gonna say just we do not have statistical significant evidence to make a conclusion, etc. That's the idea behind that. Where was I? Yeah. So this is the other example with the Chinese experiment right here. Your p-value was less than alpha, you're gonna say reject HO. You're gonna say there is statistical evidence, similar evidence to support the claim that the person of Chinese descent that fell after 1 year is different. Now we have evidence for that. Okay, in this case, you have HO or H0, for which you have P was equal to 0.90. And then you got HA or H1, for which P was different than 0.90. Because the p-value is less than that, means you reject HO. So I'm gonna reject the first one. That means I have evidence for that. This is correct. That means it is different from 0.90. That's different. This is acceptable. Okay. So this is what I'm gonna be doing. I know some of you probably don't like to use, don't use StatCrunch. While you're on your computer, I would like you to see if you can go either use the TI-84, you can use the TI-84 as well, but let's try to use StatCrunch and try to do the following problem. Okay, I'm gonna help you out to get the ideas. So let's go back here. I'm gonna skip those. Right here, I'm gonna skip that thing. Yeah, how about the stop is just for you to read. Page 64, let me see. No. 64, I guess, yeah. Now, this is the problem, okay? And then this is the question. It's going to say, historically, the percentage of US residents who support stricter gun control laws has been 52%. A recent Gallup poll of 1,011 people show 495 in favor of stricter gun control laws. Assume the poll was given to a random sample of people. So remember, random is very important. Okay. So if you have that, there's the claim that the proportion of those favoring stricter gun control has changed from 0.52. So we're gonna do perform the test hypothesis testing using a significant level of 0.05. This is by default 0.05. If I didn't give it to you, you can assume it's 0.05. So to help you out, I'm gonna try to help you out a little bit. So here, the general idea that what is acceptable is that 52% of people support stricter gun control laws. Okay, that's mean, and I have my P as 0.52. Okay, so we want to know whether this idea has changed. Okay, this is a claim. The claim can also be, we want to know whether this idea changed. So I don't want to boot claim for now. So that's me what I'm going to be doing. This is going to be my HO. That's going to be my H1. Or HA. That's going to be 0.52. Okay. Once I got that, I got my success. X over N. That's going to give me P hat, which is going to give you 495 is the success over 1010. That's success. X will be the success. And then N will be the trials, number of trials. So I hope that you guys have your canvas open. I don't know if you guys can go ahead and try to put inside this value inside your start punch as a practice. I'm gonna give you about 5 minutes. You shouldn't be taking more than 5 minutes, and then for you to do it. So again, you're gonna go to start, proportion, and proportion summary. Okay, I'm gonna repeat myself for 5 minutes while you guys look at it. Okay. Again, if you have any question, you're welcome to ask me. I also have an announcement to make. For those of you who have 90% for test number 1, 90% for test number 2, if you also get 90% or more for test number 3, the final exam will be optional for you. Okay, so that's me. If you have 90% or more for all 3 tests, test 1, test 2, and test 3, there is no need for you to take the final exam. If you have less than 90% for any of those tests, whether it's been dropped or not, whether it's been placed or not, you'll have to take the final exam. Because if you don't take the final exam, the maximum point I will give you is a D. So you're gonna have to take the class, okay? So again, if you have 90% for test number 1, 90% for test number 2 or more, and 90% for test number 3 or more, which one is coming right now, the final exam will be optional. What I will do, I'd average test 1, test 2, and test 3, and give you a 90% or more for the final exam. I will send a notification about it a few days or a few weeks, I don't know, probably next week, I don't know, before test number 3, okay? Just want to let you know that. Okay, let's see. So assuming that it has been working on that thing. Let's see what we can see now. Let's do it. First of all, this is your claim. That's the claim that the portion of those sciences has changed. This is the claim. We don't know whether it's that change. So we have the hypothesis as this two right here. Okay. So again, 1 is equal to 0.52. The other is not equal to 0.52. Okay. So your number of successes. Okay, we already saw that one. Okay, so it's gonna be, you have to do one proportion z-test. It's random because it says so, and then you're gonna double check whether if you have a sample size is large enough. As you can see, both of these numbers are bigger than 10, so it's large enough. Okay. All right, it's large enough. This is a large population. And after that, when you enter the value, your success is 495. And also extra, then you're able to get this is a test statistics as this value, and your p-value is 0.051, 0.0531. Okay. What we're gonna be doing, you're gonna compare them together with the alpha. Okay, this picture is taken from a TID3 or a TID4. Okay, if you tell it should be about something like this, okay, because it's gonna be a two-tail. So this one say reject HO. If the p-value is 0.05 or less, okay, or do not reject if you have more than that, okay. So because the person is not significantly different from 0.52, because your p-value, which is, what was it again, 0.05, 0.0531, 31 is bigger than alpha. Okay. So I'm gonna be say do not reject HO. Okay. So if you know reject HO, whenever you look at this, the significance earlier, got P naught. No. Let's see. See where's that? You got HO and H1. And H1 or HA. This one was P not equal to, what's the number again? 0.52. This one, that's going to be P equal to 0.52. So this one said do not reject HO. That means this is okay. The bottom one is not correct. We have no evidence for the bottom part. Okay. So you can say the percentage is not significantly different from 52%. Okay, that's another way to say it. So there are many ways to express the idea. Okay, again, fail to reject HO. So there is insufficient evidence to make a conclusion about the percentage being different. That means there's no evidence that it is different. Okay. So, I mean, we express them different ways. So make sure you got the idea. I will always start the graph on top here. That I put over there, I'm going to put in red right here. This is a good guidance. This one, whenever I use it, because when I say do not reject HO, that means HO is fine. The problem is H1 or HA. So I will reject HA. That means there's no evidence for H1 or HA. Or I can say insufficient evidence to support the claim. that it is different, something like that. So use that kind of approach. So the p-value is supposed to be an extreme probability. It has to be as extreme as possible. I defined it for you last class. Is an extreme value. Like if you cross it, you're gonna go in the critical values. That thing is like what we don't want to have. Again, whenever we talk about critical p-value, again, if you go to got something like this, and then this is alpha. This is alpha. If your p-value is bigger than alpha, when a p-value is fine from the data that you're working on, you're gonna be able to, you're gonna help you to decide whether to reject. If your p-value fall here, and in the reject condition, you're gonna have to reject. If your p-value fall in front, you do not reject. Okay, so apparently, if you have 95% on something, 5% you don't want to have it, and the 5% is this guy right here. Is the alpha I'm talking about. This is the 5% right here. This is what you don't want to have, but the rest is, and the rest is 95%. The p-value is fine whenever you do your on your study. Whenever you do your study, you got a test statistics based on the research that you do. You generate that p-value. If the p-value fall in the rejected region, you're gonna say you'd have to reject the idea we're working on. If it doesn't fall in the rejected region, then your study is fine, something like that. Okay, and it's hard to express, but you should go and review that little note right here on p-value. Where are you? Right here, you can review this little notes. Right here. See, you can review that little example here, that notes, to tell you what is the p-value is about, okay? Did I answer your question, Mr. Jacob? Okay. So we're gonna have to end the class here. I'm gonna upload the notes for you. There are some stuff on the notes I didn't really view, but it's for you to read. But also I would welcome you to ask me a question about them. The concept is the same, but I would suggest you, to ask me a question about them whenever we have office hours. Okay. So what I will let you go, I will let you go early and go within them. Then next week you can just make more questions about it whenever we have office hours. Okay. So any questions for me before I let you guys go?